polynomial division. Let's have a look at it then, okay? If I want to integrate something like this, I need to be able to use polynomial division and possibly partial fractions as well, to be able to simplify the integration. So the reason why we're looking at polynomial division and partial fractions is so that at the end of the day we can integrate functions like that. So from an engineer's point of view, integration is something that we very commonly do because we're often after the area underneath the curve. So that's how we do it, we integrate. So we're going to come back to problems like that at the end of this section on partial fractions and polynomial division. And they'll form part of your assignment, the first assignment you're going to get to be able to do integrations like that. So let's look at polynomial division. Here's an example of it. Well, integrate x cubed plus 3x over x plus 4. That's a polynomial on top. So it's just a word we use for an expression that involves lots of powers of, in this case, x, but it doesn't have to be x. So if you've got an expression that involves all these things, it's a polynomial. It's top heavy. How do I know it's top heavy? Because of the cube on the top right. The power of x on the top, the highest power of x on the top is higher than the highest power of x on the bottom. So it's top heavy. It's a fraction. It's a top heavy fraction. And we use polynomial division to simplify it in the same way as we would do a division for a top heavy fraction. So the first thing I want to do is just do a long division for a fraction, okay, to see how that works. This expression on the top in the blue brackets is yes, that's right, yeah. It's just a word we use to describe an expression like that, a polynomial expression. Okay, let's have a go at this, okay? This could be a fraction. 5,205 divided by 4. 5,205 over 4. It's a fraction. It's a top-heavy fraction. So if I get a top-heavy fraction and I want to turn it into a mixed number of whole ones and whatever's left, the remainder, I then do a division like this. Okay, so I do 4s into 5,205. What would I do? Right, goes once, right? Yeah, okay, so that goes down here. 4 into 5 goes once, so 4 into 5 is 1. Yeah, so do the takeaway. 5 take away 4 is 1. Bring the 2 down. 4s into 12 go exactly. Okay, so 4s into 12 go 3. What are 4 3s? 12. What's the remainder? Nothing. So bring down the next. Well, there's nothing there. So 4s into 0, 0. Okay, so you bring down the 0. 4s into 0 goes 0. So remainder 0. Bring down the 5. 4s into 5 go, which is 4. Remainder 1. Yep, and carry on. Or you can say remainder 1, you've got 1 left, okay? Now, I don't know whether you would have done it like that. When I was at school, I used to go 4s into 5 goes once, remainder 1, so the little 1 went here, and then 4s into 12 and so on, okay? But this is how you might set it out if it's a long division. Let's go through it. And then I'll just pause while you write it down. So don't write it while I'm talking. I'll give you a chance to write it down because this is exactly what we're going to do with an algebraic expression. So 4s into 5 goes once. What are 4 ones? 4. So 5 take away 4 gives you the remainder. which is 1 in this case. Then you bring down the next value, which gives us 12. 4's into 12, 3 times. What are 4 3's? 12. Find the remainder, which is in this case is 0. Note this particular bit. Bring down the next one, which is a 0. 4's into 0 goes 0. That's a very important step, because otherwise we'd miss out that 0 on the top. Okay, and then we say, okay, bring down the next value. 4's into 5 goes once, remainder 1. So we end up with 1,301, remainder 1. I'll just pause while you make a note of that. Just terminology. This number on the outside, the bit on the bottom, is called the divisor. So when you're doing a division, so that's like the denominator in the fraction. And this bit inside the division sign is called the dividend. So that's the numerator on top, effectively. So I might try and use those words as we're going through to describe the top, the inside bit and the outside bit, the divisor and the dividend. Bottom into top. Okay, let's try it then on this one. You run through with me what steps are going to be for this one. So what we'll do is I'll just pause this for a second, you have a go at it, and then we'll go through it together. So 37's into 4 won't go. 37's into 43 goes once. So 1 goes on the top. So what is 37 times 1? 37, which goes underneath. And we work out the remainder. 43 take away 37 is 6. Bring down the next number, 68. Now 37's into 68. So carry on. Have a look. Oh. Freeze. Okay. So next step then, 37 to 68 goes once. So what is 1 times 37? 37. That goes underneath. What's the remainder? 8 takes 7 is 1. 6 takes 3 is 3, remainder 31. Bring down the next number, 315. 37 into 315, well, I know 10 lots of it is 370, so half of that is 150, 185, so that's 5, so I'd guess about 7 times. So I'd have to work it out. What's 37 times 7? 7 7s are 49, 21, 259. So I need another one, don't I? It's going to go at least once more. It probably will be 8, in fact. So 8, which goes there. So what is that plus another 37? 9, 16, 5, 6, 7, 8, 9, 296. So 296. So what is 37 times 8? 296. Find the remainder, that's 19. Bring down the next number, 192. 37 to 192, well, we've worked out what 5 was, didn't we? 150, that was about right, wasn't it? So it's probably 5 times. That's 150, 185, isn't it? So 5 times it is 185. If I'm correct. Work out the remainder. The remainder is 7. Bring down the next number, which is a 1. 37's into 71 goes once, which is 37. Work out the remainder. What's that? 3, 33. Is that right? No, 34. Yeah, 34. Okay? So, end of problem. So, the answer is, therefore, um, 478521 divided by 37 is 1185, remainder 34 what? Right, so it's a fraction, 34 over 37. So in other words, in the remainder, the bottom or the denominator of this fraction is the divisor, what we're dividing in, okay? Is there another one there? Okay, thank you. Right, just look at it for a sec. Any questions? Okay, let's try applying this to a top-heavy polynomial fraction. Polynomial fraction, I always struggle with that word, okay? So, what we do is, this is the dividend, the top number is a dividend, the bottom number is the divisor. So the first thing we do is set out the division, x plus 3 into 5x squared plus 17x plus 6. So, x plus 3 into, and then we write the polynomial expression on top inside here, 5x squared plus 17x plus 6. Yeah. Okay. Let's pause. Right, the key to these is we look at this first bit here, the 5x squared inside the dividend, and this, and we ask ourselves the question, we look at the x bit, we focus on that. What have I got to times this x by to get 5x squared? And that is 4x, sorry, 5x, times 5x by 5x, and I get 5x by x, and I get 5x squared. So 5x goes on the top. Why is it 5x on the top? Because that's what I've got to times that by to get the x by to get 5x squared. And that's the key thing, and that's what we use all the way through. So then I have actually got to multiply 5x by x plus 3, like we did on the previous one. Once we've decided what this is, what we did was multiply that by that, didn't we? To see what to find out what the remainder was. So that's exactly what we do here. I multiply 5x by x plus 3. You can do it as a little aside until you're sort of able to do these things in your head. And that gives me 5x squared plus 15x. So that's what I write underneath. That is what 5x times x plus 3 is. And then I work out the remainder. Now, because I've engineered this so that the reason why we do this, you remember what I said? I said focus on what I've got to do with that to get that. And the reason is that when I multiply them, I'm going to get 5x squared underneath. And you notice at that point that 5x squared, to do the remainder, I subtract them, 5x squared minus 5x squared disappears. And that must happen. That bit goes. If it doesn't, you've gone wrong. Okay? So then I work out what's left from the rest of it. 17x minus 15x is 2x. Now I bring down the next number, plus 6. And now I do the same thing. What have I got to times x by to get 2x? 2. So what goes at the top? I've got to times x by plus 2x to get plus 2x, so plus 2. What is x plus 3 times 2? As a little aside, what is 2 times x plus 3? 2x plus 6. So that's what goes underneath here. And we find, as I've engineered it to do, that in this particular case there's no remainder. So it goes exactly. Now, as a check, I should find that 5x plus 2 times x plus 3 gets me back to the dividend. In theory, shouldn't I? So what is x plus 3 times 5x plus 2? 5x squared plus 2x plus another 15x is 17x plus 3 2s are 6. And we're back to what we had inside the dividend. Correct. Okay? So, what do? We look at the x to get it to be this term. And then that's what goes on the top. And what have we got to times the x by to get that 5x? What is 5x times x plus 3? And that's that's what goes underneath. So I can work out the remainder. This must disappear. So they must cancel. And then I've got 17x minus 15x is 2x. Bring down the next number. And then repeat the process. What have I got to times x by to get the 2x in this case? 2. So, make a note, okay? I'll just leave it up there and pause. Okay, let's have a look at another example then. Okay, so just write that down. And again, we'll go through it, and I'll pause while you can. First step. Yeah. Multiply x. Yeah, multiply x by. Oh, right, I see. Yeah, if you divide x cubed by the x, it tells you. Yeah, effectively, yeah, that's a good way to think about it. So, what have we got to times the x by to get x cubed? X squared. So that's what goes at the top. So what is x squared times x minus 1 as a little aside? That gives x cubed minus x squared. So what goes underneath? X cubed minus x squared. Okay? So this is something that's a bit of a trick. This can trip you up, this next step. Note when I do the remainder, I'm doing a subtraction. I'm subtracting this term minus this. Okay? So x cubed minus x cubed gone. Remember, that has to happen. If it doesn't happen, you've gone wrong somewhere. But what's the next one? 3x squared minus x squared gives me plus x squared. So this actually gives me 4x squared underneath. Be careful of that double negative. And then bring down the next term, minus 2x. So now, what have I got to times x by to get 4x squared? 4x plus 4x. So plus 4x goes on the top. So now, as an aside, what is 4x times x minus 1? It's like knowing your x minus 1 tables, isn't it? It gives me 4x squared minus 4x, so that's what goes underneath, 4x squared minus 4x. Again, we've engineered it so that those disappear. Now, minus 2x minus 4x is plus 4x. Minus 2x plus 4x is 2x. Bring down the next number, minus 2. What have I got to times x by to get 2x? 2. So plus 2 at the top. And that leaves me 2 times x minus 2, doesn't it? So 2x minus 2. And again, we've got an example where there's no remainder. It goes exactly. So, what we got? Just as a reminder of the whole point of this process, integrate x cubed plus 3x squared, I'm writing the dividend down here, minus 2x minus 2 over x minus 1 with respect to x. What do? I use polynomial division. And in fact, it turns out that this equals the integral of the answer, which is x squared plus 4x plus 2. All of that just becomes this. And that's trivial to integrate. Add 1 to the power, divide by the new power. So the answer's x cubed over 3 plus 4x squared over 2, which is 2x squared plus 2x plus c. Done. So that's how you would integrate an expression like that. We think it's top heavy, so therefore let's try polynomial division on it. Try that. Okay, and I'll just pause a minute while you have a go at it. You'll find there is a remainder with this one. So I want you to see if you can, what you're going to do with that remainder. How are you going to express it? Okay, let's have a look at it together then. So, see what to do. So x plus 1 into 5x squared plus 8x plus 5. First step. Times by 5x, right, 5x. To get 5x squared. So what's going to go underneath? Minus plus 5x, isn't it? Yeah, because x plus 1 times 5x gives us 5x squared plus 5x. So what's the remainder? 3x. Next step. Bring the 5 down. Plus 5. So what do I do now? Times x by 3. So what goes at the top? Plus 3. Which gives us 3x plus 3 on the bottom. So we've now got a remainder. 2. So we can write that 5x squared plus 8x plus 5 over x plus 1 equals the top, which is 5x plus 3, plus the remainder. But how do I write the remainder? Correct, Tom, right. Whatever the remainder is, it's over whatever the divisor is, isn't it? It's a fraction. 2 over x plus 1. Okay. Oh, cool. Close that. Right. I'm going to get another one. Right. Try that. Again, I'll pause and let you have a go through it. There might well be a... no. Let's do this one together, okay? So again, make a note of it, and then when you've done that, we'll go through it together. So, first step. I 5x, what have I got times x by to get 5x to the 4, or as Tyler suggests, to get that, divide 5x to the 4 by x, and you get 5x cubed. Right, so that's what goes on the top, 5x cubed. What is x minus 3 times 5x cubed? 5x to the 4 minus 15x cubed. So that's what goes underneath, 5x to the 4. Be consistent, 5x to the 4 minus 15x cubed. Don't need to write this down unless you desperately need to, but I'm going to pause to allow you time, okay? So that always disappears, but what's the remainder going to be? Good, yeah, 18. 3x cubed minus minus becomes plus 15x cubed, 18x cubed. bring down the next. Okay. However, there's going to be a problem here, because what do I do now? I've got to end up with this next term, which is 18x cubed. So what have I got to times this by to get 18x cubed? 18x squared, yeah, that's right. So what is 18x squared times x minus 3? Answer, 18x cubed minus 38, 16, 54x squared. So 18x cubed minus 54x squared. If I were to bring down the next number, look, and this is the awkward bit, it would not be an x squared term. I have no term involving x squared. So therefore, it's as though there was a 0 in here. It's going 5x to the 4 plus 3x cubed plus 0 lots of x squared minus 2x plus 1. There's a factor missing. It's not going down in even steps of power, which could easily happen, of course. So what goes here? A 0. You can sort of think of it as a 0, leave a gap, or put a 0 in, because now to get the remainder, 18x cubed minus 18x cubed is gone, but now it's 0 minus 5x squared. 0 minus is plus 5x squared. So in other words, I just keep my 5x squared term that I got. Oh, thank you, yeah, 54x squared. Where did I get 5 from? Now I bring down the next factor, which is the minus 2x, because now I want that minus 2x term. And carry on. What have I got to times x by to get 54x squared? 54x. So plus 54x. Did I leave a term out, didn't I? Plus 18x squared, yeah. This is why it's always a good idea to wait till I've finished before you write it down. Plus 54x. So now what have we got to times x by to get 54x? 54x times x is 54x squared. 54x times minus 3 is minus... It's obviously got some sort of mental block. What's 54 times minus 3? Minus 150, 162. X. So they disappear. Minus 2x minus is plus 162x. So minus 2 plus 162 is 160x. Leaves me 160x. Where's 160x? 54 times minus 3. Gives me that. Bring down the 1. I think there's a 1 at the end, wasn't there? Plus 1. And then what do I times x by to get 160x? 160. So 160 on top. And then now I've got a little more mental jiggery to do. So that's 160. But then it's minus 3 times 160. What's that? 480. So finally they disappear. 1 minus is plus 480, so 481. So we end up with a remainder of 481. I'll just pause and let you write that down. So finally we can write, if we've been asked to rewrite the original term, which is this. I wonder if this is going to work. Yeah, brilliant. So finally, the original expression, integrate that. Actually, it turns out we're going to integrate the answer, which is 5x cubed plus 18x squared plus 54x plus 160 plus the remainder, which is 481 over x minus 3. Sorry? Because if we're asked to integrate this, we rewrite it like that, which makes it a very easy integral. We just integrate each term in turn. Okay? The integral, yeah. So add 1 to the power, divide by the new power. 5x to the 4 over 4 plus add 1 to the power cubed, divide by 3, 18x cubed over 3 plus 54x squared over 2, which we can simplify, plus 160x plus, this turns out to be actually a standard integral. It's 481 times the integral of 1 over something, which is in fact the natural log of it. Logarithm x minus 3 plus c. And we'll do some of those, Tom, but to remind you of these integrals, okay? So it's just standard integration, which we looked at last year. So why do we do this? So we can integrate terms like that, okay? Straightforwardly. Note the arrival of the log term. This sort of exponential function appears quite naturally in lots of integrals because of that 1 over. The integral is 1 over. 1 over something is the natural log. Right. Now what I would like you to do is to have a go at some of the exercises in the text. So if you've got your textbook here, turn to the chapter on further algebra, which is page 49 in the new version. And you'll see some work problems on polynomial division right at the beginning of chapter 6. And then exercise 25 on page 50. Have a go at some of those. And I'll pause for a little while you do that.